Let's do an exercise with this. A stone is thrown from the top of a building with an initial velocity of 20 meters per second straight upward at an initial height of 50 meters. The stone just misses the edge of the roof on his way down, just as in the figure. Determine A, the time needed for the stone to reach its maximum height. B, the maximum height. C, the time needed for the stone to return to the original height, and the velocity that the stone has at this instant. D, the time needed for the stone to reach the ground, and E, the velocity and position of the stone at the ground. First, we need to apply the equations of motion for this object, and we know that those are that the height is equal to the initial height plus initial velocity, t, plus 1/2 of at squared. Here I could say that this is the velocity in the y-axis, but because this is motion in 1D, I don't need to specify that this is the y or the x-axis. I know it's the y-axis. And this acceleration, we know that it's minus 9.8 meters per second squared. And I am assuming that positive is going upwards and negative is going downwards. So this is one of the equations that I have. Other equations that I can use to solve this problem is that the velocity of that object is equal to the initial velocity plus the accelerations multiplied by time. So I have these two equations. Let's see how I answer the questions they are making me. Because I know that right here the object is going to have zero velocity because he's having positive velocity stopping and then coming back. So with negative velocity, right out of the top, the velocity is zero. So I can imply that this final velocity is going to be zero. I know the initial velocity, I know the acceleration, and I can solve for t. So I will use this expression for a, and this will be 0 equal to those 20.0 minus 0.8 t. So t is equal to 20 divided by 9.8, which is 2.04 seconds. So I know that the ball needs 2.04 seconds to reach the top. The second question was, what's this height? Well, I will use this expression here. So this is the one I've used so far. Now I'm going to use this other expression where that height is what I want to find. So y is equal to initial height, which was 50 meters. That's if this is the origin, which is 0, this is initial position is 50 plus 20 multiplied by time. I know that this is the time, 2.04 minus 1/2 of 9.8 times 2.04 square. And if I just use the calculator for this, I find that the height is equal to 81.74 meters. That's question B. Now let's go for question C. I want to know the time and velocity when it's coming down, because I have the same acceleration going upwards and going downwards. The acceleration is constant. I know that the time that the ball needs to go from the roof to the maximum height is the same time as going from the maximum height back to the roof. So I know that the time is going to be twice this number here. So this new time, so this would be t equal to 2.04 seconds. This is going to be t prime, is going to be twice that time. It's going to be 4.08 seconds. So it needs twice to go up and down. So what about the velocity? Well, I could apply the same symmetry concept or idea, and I know that the velocity is going to be the same one. I wouldn't distinguish if the ball is going upwards or downwards if I just film that and have the film going backwards in time. But let's see if it's really this 20 meters per second pointing downwards. I can use again this equation here. The velocity is at time 4.08. It's going to be initial velocity, which was plus 20, gravity minus 9.8, and this is 4.08. If you use the calculator for this, you will find that this is minus 20 meters per second. So it's negative because it's going downwards, as in comparison with initially that was going upwards, and that's why it was positive velocity. So to answer D, what is the time to reach the ground, I will use this expression, and I know that the final altitude, final position is going to be 0, initial position was 50, I know the initial velocity 20, the time is what I want to find, I know acceleration, so my only unknown is going to be time. So let me remove this, and what I have now, this is for part D, so final position is 0, this is equal to 50 plus 20 multiplied by time that I'm looking for, minus 1/2 of 9.8 t squared. So remember that acceleration is negative, is minus 9.8. So I can solve this for t. This is minus 20 plus minus 20 squared minus 4 times this, which is going to be 2, it's going to be plus 980 divided by 2a, which 2a is going to be minus 9.8. Here I'm going to have two solutions. One is going to be negative. That doesn't make sense. That doesn't have any physical meaning, having a negative time. And I will keep the positive one, which is 5.83. That's seconds. So that's the time needed for the ball to go from the hand of this person up and reaching the ground. What's the position? Well, the position is just the ground, so the final position, it's going to be 0 meters. And what about the velocity? Well, I can just use this expression here. The velocity is going to be initial velocity plus the acceleration, which is negative 9.8 multiplied by this number, 5.83 seconds. This gives us a final velocity of negative 37.13 meters per second. Sorry, Albert. Negative indicating us that it's going downwards in comparison to positive that was going upwards.